For solving these things, we're going to solve by factoring. And essentially what we're going to do here is follow the same process that we've always gone through for solving by factoring. With solving by factoring, we have to get the thing set equal to 0. Then we factor it completely, and then we set each factor equal to 0. Okay? So for this one, again, I got to get this thing set equal to 0, so I'm going to subtract the 2x squared and the 15x from each side. And so what that's going to leave me with is an x cubed minus 2x squared minus 15x equals 0. And now from here I just have to factor this thing completely. I can factor out a greatest common factor of x, which leaves me with an x squared minus 2x minus 15. And now I have a quadratic left inside, so I'm going to build a bridge and factor. That factors into an x minus 5 and an x plus 3. And now I'm essentially going to set each factor equal to 0. And I kind of ran out of space here. I'll give myself a little bit more room. And so I set each factor equal to 0. So I do the x equals 0. I do the x minus 5 equals 0. I do the x plus 3 equals 0. And I solve each. This one's already solved, so x equals 0. This next one I just have to add the 5 to each side. And the last one I have to subtract the 3. So I come up with these three answers. So x equals a negative 3, a 0, and a positive 5. Okay? For the next one, again, I have to do the same thing. I got to get it set equal to 0, so I'm going to subtract the 40x from each side. When I do that, I'm left with a 5x to the 4th minus 40x equals 0. And now from here, I have to factor this thing, so I'm going to factor out a 5x, which leaves me with an x to the 3rd minus 8. I can still factor this thing further. X cubed minus 8 is a difference of cubes, so that's going to factor into a binomial and a trinomial. This is one of my SOAP problems. So same, opposite, always a plus. I take the cube root to get the x and the 2. I square the x and get an x squared. I square the 2 and get a 4. I multiply the 2 and get a 2x. And now I got to set each factor equal to 0, so I do 5x equals 0. I do the x minus 2 equals 0. And I do the x squared plus 2x plus 4 equals 0. And now from here I have to solve each. These first two are easy. This one I divide by the 5. This one I add the 2. And so I end up with an x equals 0 and an x equals 2. But then this last one, I can't solve that by factoring. I build a bridge, it doesn't work. So let's take that off to the side. X squared plus 2x plus 4 equals 0. I can either solve this by the quadratic formula or completing the square. I'm going to complete the square. I'm going to subtract the 4 to create some space. And now I do b divided by 2 and square it. That's a plus 1. Whatever I do to one side, I have to do to the other side. Now this guy's going to factor into an x plus 1 squared equals a negative 3. I take the square root of each side. So I end up with an x plus 1 equals plus or minus I root 3. And now I subtract the 1 from each side. So I'm basically using all the things that I've already learned about factoring and solving by factoring and rolling all of them into one problem. All right? So here I get the x equals a negative 1 plus or minus I root 3. So I get a bunch of different answers here, 2 of which are imaginary. Okay? If I look at the next one is quadratic in form. So I build a bridge. Two numbers that multiply to the 36 but add to a negative 13 is a negative 9 and a negative 4. And we already factored this one earlier. This was the first example we ran into. So this is going to factor into an x squared minus 9 and an x squared minus 4. And now each of those is a difference of squares, so this one factors into an x plus 3 and an x minus 3. This one factors into an x plus 2 and an x minus 2. And now I set each factor equal to 0. So I do the x plus 3 equals 0, the x minus 3 equals 0, the x plus 2 equals 0, and the x minus 2 equals 0, and I solve each. So I end up with these answers. I end up with a plus or minus 2, and I end up with a plus or minus 3. So I end up with 4 legitimate answers this time. All right. And if I take a look at the next one, this is a difference of squares, factors into an x squared plus 4 and an x squared minus 4. And then the x squared minus 4, that's also a difference of squares. So that factors into an x plus 2 and an x minus 2. Now I'm going to set each factor equal to 0. X squared plus 4 equals 0. The x plus 2 equals 0. The x minus 2 equals 0. And I solve each. The first one is the only one that's a little bit difficult. I subtract the 4. That gives me an x squared equals a negative 4. And then I take the square root of each side. When I do that, I end up with x equals plus or minus 2i. For these other ones, here I subtract the 2. Here I add the 2. So I find out that x equals a negative 2 and x equals a positive 2. So my other two answers are a plus or minus 2. That's it. So I got 2 real answers and 2 imaginary answers this time. Okay. So again, when we're factoring these things, we go through the same process that we've always gone through. Greatest common factor, then look for factoring by grouping. Check trinomials to see if they're quadratic in form. Build a bridge. Then look for your special cases, difference of squares, sum or difference of cubes. And then solving is just an extra step of setting each factor equal to 0. Okay?